Okay, accelerated math, graph quadratic equations. Quadratic basically means it has an x squared term in it. All right, and let's take a look. All right, it's asking us to graph these, and there's a parent function for quadratics, and you might see it listed as f of x equals x squared, or y equals x squared. And that parent function just says, you know what, it's kind of a U shape. It hits down here at the origin, which I missed, but anyway, yeah, that's the idea. Hits down at the origin and it goes up like that, basic U shape. And then there's different variations depending on what else you do to it. Now let's take a look at some of the things that you can do to this parent function. You can add a number onto the end here. Okay, what does that do? A plus 4 is going to shift it up. So this one's going to become something like this. Alright, and a minus 4, stop it, pen's not working, oh, I'm hitting the wrong thing. Alright, a minus 4, alright, a minus 4 is going to shift it down like this to where it crosses at negative 4 over here. So the other one crossed at positive 4 when it was positive, a negative is going to cause it to go down there. Alright, and what else could you do to it? You could put a number in front of it. For example, 2 would make this stretch, and this can be a confusing term, but a stretch is going to basically stretch it out and make it much taller. Okay, that's how I try to remember that. It stretches it out. It's taking the y-axis and stretching it upwards and making this very tall. So a tall person is very stretched, versus a short person is very shrunk. And that would be the other end of this, is that if I did something like 1/2 in front of this, so anything that is a fraction less than 1 going down to 0 is going to be what we call a shrink, and it's basically going to flatten it out a little bit. And the smaller that fraction, like if you get down to 1/10 or 1/50 or 1/100th, it's going to get closer and closer to a completely flat line. So that's where this thing is coming into play. Alright, and what else can we do in that front? We can put a negative number there. So if we put negative 2, it's going to do this flip to it. So a negative 2 is going to flip it over like this, and it also is going to stretch it out. Alright, a negative 1/2 in front is going to flip it over, but it's going to do a shrink to it. It's going to shrink it and make it a little bit shorter. It's taking the y-axis and shrinking it. Okay, so that's the basics on this, and clear that a little bit. Alright, so what do we have out on the edge here? Well, you can think of this as plus 0, and what that basically means is it crosses the y-axis. It has not been shifted up or down at all. And if you look at it, C over here has not been shifted up or down at all, and D has not been shifted up or down at all. Now D has been reflected over the x-axis. A, they tried to trick somebody into thinking that, oh, maybe this is because of the 4 out here, it's going to be a shift upwards, but we know it's the shift up is coming from this. So it's definitely not this one, and here's one with a negative 4 in it. I wouldn't have picked that one either. Alright, so now what does this 4 out in front do? Remember we said that was going to be the stretch. Okay, so this is going to be stretched out from the normal one. It's C, it's not B. This one would have had to been something like negative 4x squared, because it is negative out here. It would make it flip over and do the stretch. Take a look at some other variation. This one doesn't have much on it, so again, you can think of it as plus 0 out here, so it's crossing the y-axis. Anything out on the edge there is the y-intercept of this one, so it's got to cross at 0. Cancels that one out, cancels this one out. The up front number is whether it's a stretch or a shrink, and whether it's reflected or not reflected. Alright, here we have a negative, so it's going to be reflected. Not super mathematical, but if it's a positive, it's going to be, well, think about positive. Doesn't that make you happy? If it's a negative out front, that's going to make you sad, so it's going to be a downward facing parabola. So this one has got to be B over here, because it's negative. It's giving us a sad face parabola. Alright, now we got both things coming into play. This one's a negative. It's going to be flipped or reflected over the x-axis, so we can cancel out these two. And we got our plus 6, which was was that a stretch or shrink? No, it was yes, it was the shift up or down. And if you look at it, this one over here, 1, 2, 3, 4, 5, 6, this is the one that has been shifted up 6. Okay, so reflected because of the negative, shifted up because of the 6. Last example, let's look at this. Minus 1, it's got to cross at negative 1. That cancels out this and this. So these are pretty easy. Just kind of get used to which one represents the y-intercept or the shift up or down, and that's that value out here on the edge. The front portion of the x squared is telling you whether, well, positive is going to be a upward facing parabola and a negative is going to be a downward facing, so we know we can throw this one out. It's got to be this one. Let's double check. It does cross at negative 1. It does seem to be kind of the normal stretch thing, and it's there it is, sad face parabola. Okay, so it's letter C. Alrighty, and I think that's it on that one.